So first one, why do gases have low density? Well, what's density a measure of? Yeah, how tightly packed the particles are. So since density is a measure of how tightly packed the particles are, low density means they aren't packed very tightly. Which is true because gases have a lot of space between particles. Especially compared to liquids or solids. So then that leads us into compression. What's compression mean? Yeah, if you compress something, you force it together. So compression means to force things closer together or into less space. So gases have a high compressibility or can be compressed a lot. Okay, there's a lot of space that you can eliminate. You can push them closer and not have them spaced so far apart. So an expansion is the opposite. Expansion means to spread out. And gases also expand a lot if given the space. So how do we explain that? Why do gases expand a lot? They can compress a lot, there's a lot of space there, but why would they expand a lot? What's that? They have a lot of space, but their particles are far enough apart that intermolecular forces aren't affecting them. Plus, what's the other thing that all particles have going for them? They're always moving. Yeah, so they're moving, and because gases are moving more than solids and liquids, they have more freedom of movement than solids or liquids do at the same temperature. So expansion means to spread out. Gases also expand a lot if given the space, and that's because gases have more freedom of movement than solids or liquids. Very little or no intermolecular forces slowing them down. So they can spread out easily. So as soon as you give them more space, they'll take it. So if you have a can of compressed air and you poke a hole in it, it'll escape. It'll keep escaping until there's equal amount of air inside and outside. At least the density of the air is equal inside and outside. But if you take the cover off a can of soda, you don't have to worry about all the soda jumping out of there or flowing out of there unless you poke a hole in the bottom, then you might have a problem. But gases have that complete freedom of movement. There's little or no intermolecular forces pulling between them because they're just not close enough together. Once they're close enough together, once gases get close enough together for intermolecular forces to become a factor, that's when we call it a liquid. Because now it doesn't have that freedom of movement. It has to stay in one area. It can still flow, but it can't just go anywhere. Okay, diffusion and effusion, these are really very similar ideas, concepts. Diffusion is the random scattering of particles throughout the sample. So your sample could be like, air in a room. Let me say perfume through the air in the room, or it could be something like creamer spreading through your coffee. That's diffusion. And effusion is also that random scattering. But they have to go through some kind of opening. So this is like air leaking out of your tire. Or this would be smelling, cooking from 2 rooms down. The people in the fax room, they smell the stuff they're cooking way quicker than we smell it over here. But we smell it way quicker than Thompson does down at the end of the hallway. And usually I'm guessing you probably don't smell what they're cooking up on 2nd or 3rd floor. There's not enough openings. It's too dilute by the time it gets to you. So why do gases diffuse? Diffuse and effuse is what we call it. How come? Why are they so good at diffusing and effusing? Liquids do it too, but they're not as fast. Because why? Yeah, they've got complete freedom of movement. So hot gases will diffuse that much faster than cold gases. Heavy gases diffuse slower than light gases. It's just like you'd expect. Light things move faster. Hot things move faster.